Hi, welcome to Microcontroller Embedded System Laboratory. The next program to discuss is to find the sum of first 10 integers. Now, before we look into the program, a quick look at these instructions: arithmetic instruction, load and store instruction, comparison, branch, and conditional mnemonics. These data processing instruction goes with the syntax as operation, condition, mnemonics, S suffix, which are optional, RD is the destination register, and the operands are RN, and you can have an operand too. The suffix S on the data processing instruction updates the flags in the conditional registers. The carry flag is set from the result of barrel shift as the last bit is shifted out. The N flag is set to bit 31 of the result. The 0 flag is set if the value is 0. We have conditional mnemonics. These are postfix to the instructions. These mnemonics control whether or not the core will execute an instruction. Before execution, the processor compares the condition attributes with the conditional flags in the CPSR. If the match, then the instruction is executed, otherwise it is ignored. Say for example, the mnemonics EQ. This condition mnemonics executes only when the 0 flag is set. NE, that is not equal, is going to execute if the Z flag is clear. So the capital letters is going to indicate the values are to be set, and the lowercase letters indicates that the value are to be cleared. The next instruction is the arithmetic instruction for doing addition and subtraction. We have an add instruction which adds the contents in the register R1 and R2, and the result is stored in R0. We have another instruction called as add with carry, which adds the contents of the two register and the content of the carry flag, the result being stored at the register R0. Subtraction, subtract the contents R1 and R2, and the result is stored in R0. A look at the addition and subtraction instruction. So as has been said, we have the values 1, 1 and 2, 3 in the registers R1 and R2. After execution of this instruction, the result of the summation is stored in the register R0. When we have sub S, where sub S stands for subtraction and S is a suffix with the instruction, it is being asked to reduce by one value with the register R5, and as you have a suffix S, it is going to update the CPSR flag. Now on execution of this instruction, we have a carry flag being set. Looking at another example, we have R5 with the value as 1, and when you decrement it by 1, we see that the 0 flag and the carry flag is set and N flag is cleared. The next instruction is the compare instruction. The compare instruction performs the subtraction but does not store the result, only the flags are updated. Compare allows you to compare the contents of the register or the register with an immediate value, updating the status flag. Now here we have the values on the comparison R0 and R1. If the two values are equal, then the Z flag is set. And if the value of R0 is greater than R1, N flag will be equal to 0. When you can also have a comparison being made with an operand and R0, at that time, if R0 is equal to 1, 0 flag is set. And if R0 is greater than 1, N is going to be 0. Similarly, we can have a logical shift by two shifts being done on the left side for the contents of R1, and that value will be compared with R0. The next instruction is the branch instruction. On encountering a branch instruction, the ARM processor will jump immediately to the address given. A point to be remembered here is that The actual value stored in the branch instruction is an offset from the current value of the PC rather than the absolute address. So here in this example, we have a branch instruction followed with a conditional mnemonic NE, that is not equal to, and it goes back to the label location called as loop when Z is equal to 0. We have another instruction called as load and store, which is going to transfer the value between the register and the memory location. A load instruction, that is LDR, moves the value from R2, that is a memory location specified in the register R2, into R0, whereas store is going to transfer the contents of the register R0 to the memory location pointed by the register R2. Let's start tracing the program now. The program is divided into two regions, a code block and as well as a data block. Code block is read only by default. That means it contains the machine instruction and it is the place where you can only read. A data region, which is labeled as data 2 in this program, is read write by default. That means at the time of execution you can read and as well as write in this area. We have a data definition directory to insert the constants in the assembly code. DCD stands for Define Constant Data. This allocates one word of memory aligned on 4-byte boundary. Remember that DCD is going to allocate memory for 4-byte boundary that we will see when tracing the program in Keil. Now we have an entry and start, which is a label, and this indicates we start with the machine code instructions. We are going to use three registers, R5, which is a counter, R0, which contains the sum of the numbers, R1 are the numbers that we are going to add, that is from 1 to 10. Here we have an instruction called as sub S. S is a suffix, as said earlier, for data processing instruction, and on doing this operation it is going to update the flags. The flags that we are interested in is 0 flag and as well as the carry flag. Now R5 is initialized to 10 as we are adding 10 numbers. R0 is 0, which contains the sum of numbers. R1 is the first number that we want to add, so R1 is made as 1. So the first row is our initialization step. Now the next instruction is add the contents from R0 and R1 and store that back in R0. So it adds 0 plus 1 and the summation is 1, which is stored in R0. We increment the second number which is there in R1 register. So R1 is going to be 2, and we have finished adding the first number. R5 is decremented by using sub S. R5 becomes 9 and the flags, that is R0 flag and carry flag, are going to change. Now carry flag is set to 1. It compares whether R5 is equal to 0. Now the value of R5 is 9 and it is not equal to 0. So because we have a branch instruction, branch not equal. Since the 0 flag is not set, it goes back to the loop. Again, it adds the value from 2 plus 1 and the value is going to be 3. R1 is incremented, R5 is decremented. 8 is not equal to 0. Again, 0 flag is not set, it goes back to the loop. In this way, it iterates till the last value of R1 is 10. Once it is 10, it adds that number is 55, R5 becomes 0. Now, because on comparison R5 equal to 0, that is 0 is equal to 0, at that time 0 flag is set. When the 0 flag is set, it comes out of this instruction and the next instruction is executed, that is LDR. R4 comma equal to result. This instruction stores the address value of the result and it is moved to your register R4. Result is a label given to our DCD which is initialized to 0. The address is moved to the register R4. Now we have store, that is R0 now contains the summation of the first 10 numbers. Now here decimal is 55, hexadecimal is 37. So the value 37 is moved to the location labeled in R4, and we have a branch instruction going back to the loop. As seen earlier, this is a proper way of ending the program. It goes in an infinite loop. This is the tracing of the program.